Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott. And if you'd like to be part of our show today, call in. Give us a math question to do, maybe from your homework. If you're in Bakersfield here, give us a call, 636-4357. If you're in San Luis Obispo County, you can also call us. The number's toll free, 866-636-6284. You can email us your question at dothemath@kern.org. And of course, we're all over social media, Facebook, Instagram, Twitter, YouTube. If you want to watch us online, you can do that as well. dothemathonline.net.
All right. Do you follow any of those social media things that we're all over?
Not a social media guy, no.
Neither do I, but I'm glad that we have people that are able to get that thing and get it going and get it out.
That's
because
right.
A lot of people follow that stuff, I mean, on a regular basis.
Oh, yeah.
Pretty constant during the day, I would say.
That's right.
And nice to see that they follow Do the Math, so we do appreciate that. We do have a very special guest in studio. We'll be speaking with that young lady in a little bit. We'll be visiting with Devin out at California Resources Corporation and talking with a few geologists and what they do. Some pretty cool things that these guys do, not just going around digging rocks and, I mean, some of that involved, but some of the other things behind the scenes. But before we get to all of that, let's first take a look at today's Math in the News. So this past summer, did you have an occasion to go on vacation or any place you've been waiting to go to for a long time, or any big activities over the summer?
Like to visit family. Always make it to the beach at least once or twice because, you know, it's a little warm in Bakersfield. So we got to get over there.
Go and cool off a
cooler
little bit.
weather. That's right. Next time I'm over there, I got to try out the ice cream shop, right? Doc's.
That's right. Doc Bernstein's.
Gotta give it a try.
They've got locations in a couple places over on the Central Coast. So you go over there and let them know you're associated with Do the Math, and let's have Doc special.
All right.
And they'll go, all right,
Look
what do you
forward to
want?
that
And
one.
that'll be Doc specials for the day. So, but they very, very accommodating over at Doc Bernstein's Ice Cream Lab. So if you call in from San Luis Obispo County today, you automatically receive ice cream courtesy of Doc Bernstein's. But anyway, my wife and I, we had an opportunity for our anniversary to go to Ireland this year.
All right.
So naturally, I'm looking through the newspaper, seeing what's going on in the Emerald Isle and things like that. And this caught my eye, a Venn diagram. And there aren't too many math books in the elementary grades that still use Venn diagrams for math.
Right.
Okay. So this is one that caught my eye. So we can take a look at the problem right here. And this is kind of a complicated one with the number of circles that we have here.
It's a good thing it's in color.
Right. Can you work out the two areas of the diagram that represent male skateboarders who have broken an arm and a collarbone but never been concussed, and skateboarders who have been concussed and broken an arm but not a collarbone and are girls? So there's a lot of information to look through at that right there. So you can see the female, the concussed, the broken collarbone, the broken arm, and there's a lot of different circles. So what you're doing is you're looking for areas that overlap in these different areas to find exactly what you're looking for. But I figured that was a little too complicated for us to go into right here. So we'll take a look at the one that I've got up on the board.
Okay.
So we've got prime and even numbers, and we can take a look at the prime numbers are 3, 5, and 7, just some numbers between 1 and 10. So prime numbers where only 1 and that number itself can go into that number. So that number is divisible by only 1 and itself.
Right.
An even number, such as 4, 6, and 8, divisible by 1 in itself and at least the number 2.
Right.
But we can see 2 is in the center. That's in the overlapped area because 2 is an even number and it's also a prime number. So that's kind of an easier way to see how the Venn diagram works on a lower level right there. And that is today's Math in the News, straight from Ireland. And let me see if they have the date on this actually, when this was. July 12th.
All right.
So I've been holding on to this paper since July 12th, and now we are through with it. Today's Math in the News. In studio with us right now, we have Love. How are you?
Good.
And why don't you let everybody know where you go to school and what grade you're in?
I go to Stockdale Elementary and I'm in 5th grade.
How's 5th grade going?
Good. I like it so far.
You like it so far? Well, that's good you like it so far because you're going to be there for a little while, right? You've been halfway through the year. So you like it so far. Is there anything in particular that you like?
Math.
You like the math. So is it because it's more challenging or you kind of got it and you're comfortable with it?
I've got it and I'm comfortable with
Well, you know what? Everybody likes it when they're comfortable with it. So we're going to work on some things with you today that you're comfortable with because you said you started working on division. And we'll let you do a little bit of that, but then we're going to get you a little uncomfortable with some other mathematics. Is that okay?
Okay.
All right. You know what? Why don't you head on over to the board because Scott found a little something. And Scott, this is the Romanian soccer team, football team. What is?
Right, this is the Romanian national soccer team, which,
Okay.
if you're going to compare that to our country, it's probably like, the Super Bowl champions of the United States because it's such a national icon. So everyone probably in Romania knows who these guys are.
So they know who they are, and you said that the math scores in Romania were starting to get a little bit lower.
Right, the statistics came out, and they rank all the students in the whole world about how their test scores are, and Romania started to go down the list. And so
they
the
weren't
soccer
happy about
team
that.
took it upon themselves to decide to do something about that, knowing that so many young people looked at them, and they decided to change their uniforms.
And I think this is a very clever way to do this, and it would be cool to see other teams do it.
Right.
And you can do it where you, go ahead and show what you've got, and we're going to
Sure.
have Love kind of work on
Sure.
some of these.
So, Love, take a look at some of these numbers here, right? We have a hard time figuring out what number you are. So if someone had a foul called on them, or someone had to leave the game, or someone had to substitute another player in, you look at this guy and say, well, what's your number? We have to do a little bit of math to figure that out, right? Can you grab a pen real quick there? We want to figure out what this guy's actual number is. So can you write it over there? 2 times 2 plus 2. So tell us a little bit about the order of operations there. Which one would you do, the times or the plus first?
times.
That's it, you got it. So what do you get? Yep. That's it. So this guy's number right here is 6, even though he's got a whole bunch of 2's on his back. And if you look at the next one next to him, it says 2 times 3 to the 2nd power. So you think you can squeeze that way up there in a little bit smaller numbers? And we can kind of talk about how we'd work that out. 2 times 3 to the 2nd power. So just tell us a little bit about how you'd work that problem out. Which one would you do, the times or the power?
The time.
You have a times, right? And you also have exponents. Remember your order of operations? First thing we look for is parentheses. No parentheses there. Next thing we look for is
Exponent.
exponents. That's it. So 3 to the 2nd power, tell me in your head, what's that number?
9.
9, and then times 2?
18.
18, there you go. So can you put it equals 18 there? So those are the old boring numbers, right? This guy could have a 6 on the back. This guy could have an 18 on the back. But this makes it a little more interesting. The one I thought was most interesting is the one way over here. It says 46 ... 2. Any idea what that means at all?
Division.
Yeah, it is division because it's a ratio. 46 ... 2. Let's see if we can squeeze it right there on the board. That's it. So that's a ratio, 46 to 2. And just like you said, you could do some division. You could make it into a fraction and put 46 on the top and 2 on the bottom. So think about this in your head. What's 46 divided by 2? It's a good challenge for you today.
23.
23, that's right. So this guy's number right here is 23. So they came up with some different ways of writing numbers. I thought that was kind of a creative thing. What do you think? What would your number be if you were playing soccer in Romania?
9.
9, all right. So maybe we can make up at the end of the show, see if we can get you a new soccer number if you had a Romanian soccer jersey.
You know what? Let's take care of that right now. So
do it.
how would you represent 9 on the back of your uniform other than just that numeral 9?
Without just writing 9.
4 times 2 plus 1.
I like it.
Yes,
That's
sweet.
a good way to do it. So
There
the
you go.
back of your jersey would say 4 times 2. 4 times 2 plus 1. There you go. And you'd fit in with the rest of it. And that's 9. Good. And that's my favorite kind of math page. It gets a little messy. That means you're doing a lot of work. That's a good thing. Well done. I like it. Nice
Nicely
job.
done, love, right there. And I like that because I was hoping she was going to have 3 things in there
Right.
instead of just 1 times 9 or 4 plus 5.
Sure.
Because that way the students need to know the order of operations instead of going 4 times 2 plus 1 and getting 12.
Right.
Because they may go 2 plus 1 is 3, 4 times 3 is 12. An easy enough thing to do
Right.
without understanding the order of operations.
And the Romanian soccer team, hopefully that's the exact kind of conversation that they got going on in classrooms in Romania.
And perhaps it will spread now
There you
that it's
go.
on Do the Math.
Yeah, maybe Dallas Cowboys will pick it up next.
Yeah. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We will have Love working on some other mathematics in a little bit, but right now we're going to head out with Devin and see our friends at CRC.
How's it going, everybody? We're here live at California Resources Corporation in Bakersfield. We've got a lot to talk about today about what the company does. We're going to go deep underground with the work here and speak to some of our geologists and engineers about what exactly we do here at California Resources Corporation. Joined right now by Nathan Reich. Nathan, how's it going?
I'm doing great. How are you?
I'm doing well. Love being in the control center, Information Station Central. There's a lot of monitors here. I don't know what any of them do right now, so hopefully you're going to help us walk through exactly what's going on.
I'll try to do that. Okay. My name is, as Devin said, my name is Nathan Reich. I'm a geologist with California Resources Corporation. Our company finds and produces oil and natural gas from California, and we operate fields from all the way down in Huntington Beach, nearly to the northern border of California. And we're going to talk about one field today, which is at Elk Hills. We're sitting right here in Bakersfield, right about here, and the Elk Hills field we're going to talk about is right over here. We've got a team of geologists and engineers that work and try to optimize the production from that field. And the first one we're going to go to is Casey Coddington. She's a geologist on our shale team.
So Casey's here to kind of guide us through exactly what we're looking at here. I mean, there's a lot of oil to really explore. From what I understand, the company is one of the largest producers of oil and natural gas production in the state.
That's correct. And in this field, we have about 700 active wells. So it's a lot of data to look at every day.
And you're able to monitor a lot of that from this location here and use the information you get to calculate exactly how much you're able to produce as far as the resources available to you. And, you know, maps like this are able to help us visualize that. So could you kind of just walk us through what we're looking at here?
Sure. So right now, we're looking at the 2B section of the 29R field. So the section is just these black lines here and this green line on top, and that's about a square mile. And then, so what we were looking at is we have this well here, 352C, and we wanted to know how much oil is just in this section. So that well's pretty representative of the entire section. So we're going to use the data from that well to calculate how much oil is in that section.
So it's a good cross-section, just taking a look at this 1 square mile of this oil field out in Elk Hills. And you're able to do this in real time. The information you see right now is what's actually happening, you know, how many miles away from it? About 40 so
Yep.
miles from where we are. So if we take a look at this, there's a lot of different ways that we can look at a square mile. A lot of times we think of a mile in terms of feet. We think of 5,280 feet, or number of yards, 17,060. We're using acreage here as far as calculating this measurement. So kind of explain how we're measuring the acreage through the square mile here.
So the acreage here, so we know that 1 square mile is about 640 acres. And then it's something I can also go in and measure just if I want to be sure. So I did measure that earlier, and it is 640 acres for this.
So how do we use the information here to figure out the amount of oil or the number of barrels that is able to be produced from this field right now, from
Okay.
this section?
So I have a formula for that, and that formula is here. So I need to know a few things. I need to know the area, I need to know the thickness, so how much rock is under the earth that we're targeting.
Okay.
And then the porosity. So what the porosity is in a rock, you have stuff that is actually the rock, and then you have little spaces in between the parts of that rock, and that's the porosity. So we need to know how much of our rock is porosity, and then in that porosity, how much of it is filled with oil. So you can have oil or water, and we want to know how much is oil. And then we need to know, well, of the amount of rock we have, how much of that is what we call net reservoir. So I can show y'all a correlation over there that kind of shows what that's talking about. And then finally, I have this constant over here. So this constant allows us to get our measurements from acre feet of oil or cubic feet of oil into barrels.
So if we use some of these values as examples, and we know the area of the space that we're looking to measure, and then we're using all of these other variables to tell us exactly how much oil there is in the amount of rock that you're looking to drill through or explore, you're able to calculate through multiplication of these values
Correct.
exactly, or at least, at the very least, a rough estimate of how much is there.
Correct. So what I do is I go and I plug in the data I get and carry down my constant. So what I would come up with is in this section, there's about 500 million barrels of oil. So.
I mean, and the fascinating thing from a student perspective, and I hope you guys at home can kind of see this, these are numbers that we can very easily manage and manipulate. Of course, you can put it in a calculator, which I'm sure is a common practice once you start working with these values professionally. But you could see how you can rearrange some of these numbers with some properties. So for example, I'm looking at this 0.5 here, and look at that as almost as 1/2, and use that over here with a friendly number like 2,000 and say, well, if I combine these two together, that's really just 1,000. I can do something very similar here with this 0.25, which I can recognize as 1/4, and look for another friendly value. Maybe what is 1/4 of 0.4? Well, that would be just 1/10, right? Or maybe I can use this with 640 and calculate that as 160. So now I have fewer numbers that I need to multiply and calculate through. And you know what's great about this presentation of this, Casey, is that this is math that kids at home can do on their own.
Great. Yeah, this is 4th, 5th grade math that's easily done.
So we're going to go ahead and hold on to that value. We're going to look at this information, and we're going to pass it on to another one of the engineers here at California Resources Corporation a little bit later on in the show. But for now, let's head back to the studio. Mike, back to you.
All right, thanks for that, Devin. 636-4357 is the phone number. Speaking of, we need to have Wasa, an 8th grade student at Warren Junior High, give us a call. Wasa, an 8th grade student at Warren, go ahead and give us a call. The phone numbers are at the bottom of your screen, and you do know our phone number because you phoned in, we did one of your math problems, and you actually won a prize, but we need to know how to get you that prize. So Wasa, an 8th grader from Warren, please give us a call so we can take care of that. Right now, we will go to the phones, and our first phone call over the afternoon. Morgan, how are you today?
I'm good.
And you phoned in late yesterday, correct?
Yes.
Good. I'm glad you're still working on some more math. As soon as you're ready, let's hear the one you're working on right now.
Okay, so it's 16n plus 3 plus 4n equals 103.
103, is that correct?
Yes.
Okay. Well, Morgan, what do you want to do first here?
We're going to add the like terms, which is 16n and 4n.
I like that. What a great idea. I'm going to go ahead and circle them so we know which ones are like terms, and we will put them those together. So what's 16 plus 4?
20, 20n.
20n. And we still have that plus 3, right?
We bring that down.
Yeah. And that equals 103. All right. What's next? So far, so good.
We have to try to get rid of the 3, so we subtract it by -3.
Okay.
And we do that to the 103.
Do you want me to put that underneath or by the next to it on the side?
Underneath.
Underneath, okay. So we got -3 right here. It says plus 3, so we do -3. And you said on the other side as well?
Yes.
Okay. That looks like a pretty good deal. So what's +3 minus 3?
That would be,
What happens to those 3's?
they cancel out.
That's it. You got it. And you chose that specifically so they would cancel out. I like how you did that. So I'm going to bring this 20n down because there's nothing else left on that side. And what's 103 minus 3?
100.
100. All right. Looks like we got one more step left. What's the last part there, Morgan?
Now you divide 20n by 20.
Okay, and I'm going to
do
make
that
this
to
into a
the
fraction
100 too.
because fractions mean divide. So I divide that by 20. And then anything else?
You do that to the, you divide 100 by 20 also.
Sounds good. So what's 20 divided by 20 on the left-hand side?
That just cancels out.
It does cancel out, yeah. And you could, if you wanted to, you could put a 1 there because that's all we have left is just a 1n, right? 20 divided by 20 is 1. But you don't often see it that way. So if you don't want to have the 1 there, that's okay. We have to know that there is a 1 there. And then on the other side, we have 100 divided by 20. Can you do that in your head?
50?
Aha, well here's a fun way to do it. I like the way you have a 5, or have a 5 in your head, right? Let's cross off those zeros. Now we have a little bit simpler problem. What's 10 divided by 2?
5.
5, that's it. So you had the 5 right, but the zeros go away because there's 1 on the top and the bottom. Morgan, I'm impressed. Well done.
But Morgan, as impressed as Scott is, I'm not easily impressed with that. I would like you to check the problem to make sure that 5 is the answer. So let's go back up to the original problem. And Scott, if you would, maybe kind of review with Morgan how to verify and be certain that 5 is the correct answer.
Sure. At the very end of the problem here, Morgan, our result was, our answer says n equals 5, right? And so what that means is we are claiming that if you put 5 in place of n in the original problem, that was way back up here at the top, if you put 5 in place of n, that the left-hand side will also equal the right-hand side. That's what we're claiming. So we should figure out if that's going to happen, right? Okay, so let's do that. Let's go ahead and put that 5 in there for n. And so what happens is, here we get 16, and if a letter's right next to a number, Morgan, what does that mean?
That means
Well, how about this? If you have a number right next to another number, like let's say they're in parentheses, and they're right next to each other, like a 3, and then right next to that is a 4, and they're both in parentheses, what does that mean?
Can you repeat that?
Yeah, if you have a 3 in parentheses, and then you have a 4 in parentheses, and they are right next to each other, what does that mean? What is that going to be? Add, subtract, multiply, or divide?
I'm not too sure.
Ah, well, it doesn't have an addition sign, right? And I
No.
don't see a subtraction sign. And earlier in the problem we had division, that was with a fraction, so I don't see that one either. So when you see parentheses, think multiply, right? So this is a multiplication problem. And the same thing happens over here when we go and check. If you have a letter right next to a number, what that means is multiply. So we're going to multiply this together. 16 times, what was the value that we said n was? At the
5.
5, there you go, 16 times 5. And then we would have plus 3. And then we got to substitute that number again. And this 5 is going all the way back into here, and it's going back into there. So we would have 4 times 5 here. And hopefully that result is 103. That's what we're claiming is the case. So this is the way you check your answer at the very end of the problem. Okay, we're going to do some easy parts first. We know that 3 is not going to change. How about 4 times 5, Morgan? What's that?
That's 20.
20, gotcha. Now we need to go back here to the beginning and do 16 times 5. I'm sure you know your times tables all the way up to 16, right? Maybe not so much. That's all right. 16 times 5. You want to fill that out real quick?
Okay. 80.
We do have an 8 in there. You want to add a 0 to that?
8.
80. Yeah, you had the 8 part. Nice job. I'm impressed. So the claim here still is that 80 plus 3 plus 20 is 103. Let's see if that's the case. What's 80 plus 20?
That's 100.
That's 100. And we still have that 3. Is 100 plus 3 103?
Yes.
Nice job. So that is how you check your answer, because when you plug your answer back into the beginning, you're supposed to have equal sides.
There you go.
Nice job.
Nicely done, Morgan. See, that way I want the students to get used to taking that value, putting it back in there.
Right.
That way, when a student turns in their work, they have a better idea of, oh, I know that I've got that one right because I verified the answer, or I got 6 and I tried putting it in there and it doesn't work, but I don't know what I did wrong.
And you
But
can
at
figure
least
out
you
if you're
know.
wrong before you turn that test in.
Right.
That's exactly right.
So, we do have phone tutors available until 5:30. Love is ready to get back to work, so why don't you erase the board, Scott? And Love is working on division with, you said, partial quotients? All right, so why don't you give us an example of what you're working on, and you can explain it to Scott as you go along.
So what we do is 3 times 100 equals 300,
Okay.
and that's um, 100 minus
Now, can you tell me how you came up with 3 times 100? Where did that come from?
we just like do 10. Oh, wait, that's
I think
do-
it's a great idea. I think that's what I would do too. I just
Yeah.
want to know where you came up with. You have the 3, obviously. I see that one. Can you tell us where the 100 came from?
the teacher really didn't tell us. She just like came up with a number like 10 or 100 or 5 or 10.
Right, right. Okay, so far what you've done is really wonderful. I like it. In fact, if you can put a 0 back over there on the 10, I think that what you're doing is exactly right. I just want to make sure that people watching know what's going on. So tell me what place value the 2 is in.
Ones,
Ones, and then the 6?
tens,
Good, and the 5?
hundreds.
100, that's it. So we're looking very first at the 5, which is in the hundreds place, right? And so how many times does 3 go into 5?
1.
1 time. And that's where the 1 comes from. But it's not just a 1, right? It's in the hundreds place, so a 1 would count as 100. So what you've done so far is great. Nice job. What would you do next? I like how you're subtracting there. So you have a little bit left, right? Go ahead.
So 300 can't go into 262.
Right.
So that would be 1.
Mm-hmm.
Then, wait. If it doesn't go in, then I can try a different number, which would be, I can do,
Now tell me about this a little bit. Are you supposed to bring all these numbers down right away?
which numbers?
Well, you brought down the 6, right?
Yeah.
And you brought down the
Okay.
2. Oh, that's because you're
Subtraction,
subtracting
yeah.
300. I got you. Okay.
Now I can do 3 times 50, which is 1. Then 2. Then
Can you tell me a little bit about where 50 came from?
you just like have to come up with a random number, which it goes into 262, 50. And now I have to do a different number,
Okay.
which is 3, 6. I can do 3, 6 over 10, nice. 3.
So every time you're multiplying times 3 on the outside, right?
Yeah.
I got you. Okay. And you're going to pick another number.
8, 16, 24. I can do 3 times 30,
Good.
which is,
So over there on the right-hand side, you're keeping track of all the numbers that
Yeah.
you chose, right?
and that would be
Ah.
a 90,
Okay, hold on just a moment. I'll give you a little bit more room.
which is 2,
Mm-hmm.
is 22.
Oh, we're getting close.
And then
So now 3 goes into 22, pretty darn close, right?
3. Which is 7
There you go.
minus 21
Okay. A little more room.
equals remainder 1.
Okay, so there's 1
So-
left over. So tell us what goes back at the top here. You have all those numbers on the right-hand side. What are you going to do with all that stuff?
Add them.
Okay, so every number you used, you got to add all together.
Mm-hmm.
Okay, let's see what you got. 187. Remainder 1. Nice. The last thing I need to know is, again, if people have never seen this before, tell us again how you came up with these numbers. You did 100. I like that because, you know, if you look at 3 into 5 goes 1 time, it's 100. But the 50 and the 30, would you have to use 50? Would you have to use 30?
No, you just have to like come up with a different number.
Gotcha. So it doesn't matter what you use over there, as long as, of course, you have a little bit of a remainder left, right?
Yeah.
And then at the end, whatever numbers you pick, you're going to add them all up together at the end. I like that way of dividing. That's a pretty neat deal. Is there any way to check this work now? Because Mike really likes it when you check your work.
So 187
Okay?
multiplied by 3, which is 6.
Good. Oh,
Plus-
561. And hold on, what are you going to plus? What are you going to plus in there?
The remainder one.
Oh, the remainder you got to add
which
that
is
into.
5.
62. Nice. I like that. Well done. There's your check. Well done. Nice job.
There you go. Always nice to verify the work to make sure it is done correctly. Nicely done, love. We'll be back with more right after this. Today we're in Ridgecrest. We're at Las Flores Elementary School, and today we're here to Las Flores Elementary School, and we've got Charlotte right here. Are you ready to do some math?
Yes.
All right, let's go. It says estimate products. What do you think that means? What are we going to do when we estimate products?
Get the estimate for the number.
We're going to get the estimate for the number, right? So do we have to figure out what the exact answer is for this? Or are we going to estimate it? Come
Estimate
close.
it.
We're going to come close, right? So what's the first one we're going to work with?
The 4.
4 times 86, right? Okay. So how would you estimate this? Is there a way that you can think of that we could get an estimate instead of the exact answer? How would you like to go about this?
You could times it, and then if you think it's close, if it's close to the number, then you write which one's closest to the number.
Okay. So the 4, is there anything we should do with that or just leave it? 4 we could probably just leave, right? It's a single number. So let's go 4. Okay, times. Now 86. So we could round that so we can estimate it easier. So 86, what would you like to round that to?
The 6.
Okay, so if we have a 6, is that going to make the 8 go up or stay the same if we rounded it?
Go up
Go up to what?
to 9.
Okay, so why don't you go ahead and write 9? But is it just going to be 9 or is it going to be 9 and a 0?
9 and a 0.
Right, so go ahead and put 90 up there. Okay, so now this way we're going to estimate. We're going to take 4 times 86 and we're going to estimate saying it's about 4 times 90, right? Because we rounded it. So can you do this in your head? Can you do 4 times 90? What's that? What are you thinking of as you're doing it?
3,600.
Perfect. Well, so write down the 36. How did you know that it was 36?
Because I times the 9 with 4.
Perfect. And how many zeros are there?
2.
Well, there's only 1 here, right? So we'll go ahead and put 1 0 at the end. All right, because if we have just 4 times 9, what's that?
36.
And that's the 36, and we just add the 0. So 4 times 90 is 360. So 4 times 86 is about what?
3,600.
360.
Yeah,
Because
360.
3,600, we're going to put another 0 on there, right? So that's your warm-up. Now we're going to go to the big one. Okay? So what do you think we should do with the 5? Like we did with the 4, what will we do with it?
Just leave it.
Just leave it. So go ahead and write your 5 there. Put your multiplication symbol. Now we have a larger number, 2,213. If we wanted to round this to the closest thousand so that we just estimate it, get around the right answer, what do you think 2,213 should be? Because 86 we turned to 90, right?
It should be
So think about this number and the number next to it. Is this number going to make that one go up or stay the same?
Stay the same.
Stay the same, right? So go ahead and put your 2. Okay, and then how many places like this, the 6 became a 0? How many zeros are we going to have now?
3.
So go ahead and put 3 zeros after that. All right, and then we'll put equal, and we're going to have you write your answer down here, okay? So what would 5 times 2,000 be?
10,000.
There you go. So go ahead and write 10,000. Nicely done. All right. So what you did is you took 4 times 86, we rounded it, estimated it to be 4 by 90. And then what did we do with this one?
We left it.
Left the 5, right? And what did we do with this?
We rounded it
Rounded it to what?
to 10,000.
Altogether, it came out to be 10,000, didn't it? Right? Because the 2's not going to change that, so we just left it at 2,000. Charlotte, nice job estimating. And a big thanks once again to all of the staff and students. And if you'd like Do the Math to come out to your school, simply give us a call and we'll see if we can get you on our schedule for this year, and we'll come out and do a little math in your class. Right now, we'll head back out to CRC. We've got Devin once again.
Hey, thanks a lot, Mike. Back here live at California Resources Corporation, joined now by Kriti Dabadell, Operations Engineer with the company. Kriti, thanks a lot for joining us. So in our last segment, we were talking a little bit about the amount of oil that can be found or is in the reserves in some of the areas here. So that's good information for us to have. That information gets passed on to you, and so we can talk a little bit about what that means for your role here. Talk a little bit about that.
So I'm an operations engineer, and my position requires me to optimize the wells and make sure the wells are running smoothly and that we can get the oil and water and gas out of the ground successfully and make sure that we're meeting our production forecast and we're making oil, basically.
So it's important to know if there's so much in a reserve, how much you'll be able to get out during a certain time period. Because you're able to identify remotely how a lot of the wells are operating. You see that, I think, back here, and is what we were saying on the screens back here. You get a lot of real-time data as far as not just the output of the wells in real time, but over time, exactly what's being produced. So kind of describe what we're seeing here.
Yeah, so this first diagram over here, we have a pumping unit, and this represents a pumping well that we see out in the field. So this is a pumping jack that a lot of people have probably seen going up and down as they drive by. And on the pumping unit, there's a lot of pieces of information that we gather that's real time. So there's a lot of transmitters and analog data that we're recording from antennas that's going ahead and populating into the software that I get to see. So these are all examples of pieces of information we collect. And then the second graph here shows some of the production data and pressures and volumes that we're looking at that's coming from the real-time data that I just showed earlier.
So, I mean, it's interesting when we look at some of the trends here. You can see, if you look at the bottom, you have these dates. So this is kind of the general output at different times of day during the different days. We can see there's kind of a bit of a flat line here. So that might indicate, for example, that production is a little low during that time span, but then it kicks back into action. So you can see that information quickly. But the computer uses this data and processes it very quickly. So I always think it's fascinating to see what exactly the computer is doing to visualize this. And Kriti, what you've done is you've actually created a few problems that kind of illustrate the kind of math that the computers are programmed to do. And if you can check out our Facebook page, check out Do the Math online through Bakersfield at Facebook, and you can kind of work through these problems with us in real time and kind of punch them out on your own. But let's talk a little bit about some of these types of problems and some of the information you're able to draw from this information. So we should want to call out some of the abbreviations here. When we see this abbreviation, that stands for barrels, is that correct? And so when we think of a barrel in oil production, we're talking about the equivalent of 42 gallons, or 42 gallons of milk would be kind of along the same line. So we're talking about barrels. So let's talk about this first problem.
Okay. So on a monthly basis, all of our wells, they have to get tested so we can find out how much oil and water they're producing. And when we're testing these wells, we don't always test them 24 hours a day because we have a lot of wells and that would end up taking a lot of time. So this first question here is showing we want to know how much fluid production can we make in one day. So for an example, this example shows we're making 200 barrels in 12 hours. So if a well operates 24 hours a day, how much production is it making?
So because there are 2 of those 12-hour blocks in the 24-hour day, we're basically multiplying the 200 barrels times 2 of those blocks to get to
Correct.
400 barrels a day.
And then, like I said earlier, the wells, they produce oil and water, and we have to measure how much of it is oil and how much of it is water. So for this example, we're going to say the oil cut is 60%, so we want to know how much oil and water are produced in one day.
So if it's 400, so we have 60% of oil cut, that means that the water cut's going to be the remaining 40%. So we're going to know that we have to find 40% of 400 and 60% of 400.
Right, so I multiplied 400 that we got from the first problem times 60%, which is also 0.6 in decimal form, so that's 240 barrels, and then I do the same with the water, and that's 160 barrels of water.
You could probably represent these as fractions too, as 6/10 and
you can.
4/10 as well. And so from there, you're able to figure out, if you know that out of the 400 barrels of fluid that a well produces every day, that 240 barrels of that is going to be oil, then you're able to figure out how much oil is produced in this month based on the number of days in the month?
Yep, so in the month of October, there's 31 days. So if you multiply 31 days times 240 that we got in the earlier problem, you can see that we're making 7,440 barrels of oil for the month of October.
And you'll be able to use that not just for a month, but also, overcast that for an entire year and beyond to really calculate and plan out the production levels just off of one pump.
Correct. Yeah, you can use this and multiply by 12 to figure out how much you would make for the whole year.
Pretty. Thanks very much for kind of walking us through this. It breaks down a lot of the smaller pieces that make sense to a lot of our viewers. We're going to come back a little bit later on in the show, and we're going to pass this information on to another one of our reservoir engineers here at California Resource Corporation. For now, we'll send it back to the studio. Mike.
All right, thanks for that, Devin. And I do believe at the end of this, they're going to be talking about how students can get into that field, because obviously in Bakersfield, a lot of oil and production and things like that. So it would be good to find out how you can get into something like that if it does interest you. We do have phone tutors available until 5:30. Love is in studio with us, and because you're here, you'll be going at your leisure to Johnny Rockets to enjoy a meal. So we hope you are able to enjoy that meal over there. And if you go there, when you go there, because you will go there, if you remember, ask for Lydia. All right? Lydia loves Do the Math, and she's the one that gives us the certificates for you guys to go and have a meal. And just say, Lydia, give me the house special. All right? You remember that? Mm-hmm. And she'll say, what are you talking about? You go, well, Mike, on Do the Math. She'll like, oh, I can't give you that much food to eat. But anyway, we do appreciate Love being in here this afternoon. And all of the students that phone in during the day, every Tuesday and Wednesday, their names are entered into a drawing. And at the end of every day, we give away 2 tickets to CSUB Athletics. So out at CSU Bakersfield, there are a lot of, all of the different sports that they have, students are eligible to win 2 tickets to any of those sporting events. So it doesn't have to be like, oh, well, basketball is going on right now. It doesn't have to be basketball. You can go watch volleyball, soccer, baseball, wrestling, swimming, whatever event you like. So we will be awarding those later on this afternoon. Right now, we'll go back to the phones, and a 6th grader. Ian, how are you today?
Good, how are you?
I'm wonderful myself. Are you working on equations by chance?
No, it's actually correcting my test from the,
So working
from
on an
the
expression or something
expression.
else? Well, you know what? As soon as you're ready, let's hear the math problem you are working on.
Okay, so I am working on -21, and then this is in parentheses, a plus 2b plus 14a negative 9b.
Now, Ian, did the parentheses end in there somewhere?
Yeah, at 2b.
Oh, okay, gotcha. So we have some ending parentheses there. So negative 21 is on the outside, and then in parentheses you have a plus 2b, is that right?
Yes.
And then after that it says plus 14a, and then minus 9b. Is there any equal sign here at all?
No.
Okay, that's probably a good thing at this point, because we have 2 letters in there, and that gets kind of crazy when you have that going on. So tell me what to do first here, Ian. What are we going to do first?
Well, we're going to multiply negative 21 by a.
Gotcha. Do you remember what that property is called in math?
A variable.
Yeah, a is a variable, that's right. But what happens when we multiply this 21 times the a, and then you're probably going to multiply it times the b as well? What's that property called when you multiply something outside the parentheses times the things that are inside? It's kind of a math teacher thing. The distributive property, you probably heard about it before, but what you're doing is exactly that, the distributive property. So what is negative 21 times a?
Negative 21a.
You got it, negative 21a. And then next, what are you going to multiply negative 21 by?
By 2b.
Okay, so what's negative 21 times a positive number? Is that next number going to be a positive or a negative?
A negative.
Good for you. And what's 21 times 2? Can you do that math problem real quick?
42.
42, good job. And you want to keep that b in there somewhere?
Yes.
Okay.
It would be negative 42b.
Gotcha. And I'm going to go ahead and bring the rest of this stuff down because we haven't done anything with it yet, so we don't want it to go away. So I brought down the 14a and also the negative 9b. So now we have some a's and some b's. What do you want to do with those, Ian?
I want to keep them there and then later combine like terms.
Let's do that. Let's combine like terms now. So what things are alike in the rest of this expression?
Negative 21a is like positive 14a.
Because they both have some a's, right? So we're going to have some apples here. We're going to put those together. So can you do that part in your head? What's negative 21 plus 14?
Negative 7.
Good job. And we'll keep that a in there, right?
Uh-huh.
Nice job. What else, what other like terms do we have in this expression?
Negative 42b and negative 96.
Negative 9b right there. So this is a little more interesting problem. What's negative 42 minus 9?
Isn't it positive 51?
Well, we do have 51. And if you're multiplying them together, because you have a negative times a negative would be a positive, you're right. But in this case, we have two negatives, and we're going to put them together like you just did with get a 51, but it's going to stay negative. Now, it is baseball season, and it's also the end of baseball season. It's also football season as well. So if you think about two teams that are playing, the positive team and the negative team, think about this. The negative team in this case scored 42 points. That's what it says right here. And then the negative team after that scored 9 points. So at the end of the game, just like you said, it was 51-0. The negative team won. So that's how I figure out that this 51 is actually a negative.
Okay.
Because they're both negatives, you got to add them together. Anything else you want to do to put things together, Ian? You want to put the A's and the B's together at the end?
No.
Good for you. How come?
Because they're both different variables.
They're different, right? We got negative 7 apples and we got negative 51 bananas and we got a bunch of fruit, but we can't put them together. Nice job. I think you're done with that one.
Okay.
Okay.
There you go. And for that effort, we're going to send you home with a ticket to the Bakersfield Condors. So we hope you get out to a game and have fun at that. Love, we've got about 3 minutes for you to solve another problem. So we'll erase the board, and you're going to do another division problem for us, but you're going to do it a different way. Mm-hmm. But remember, you've only got 3 minutes. All right? So Scott will help keep you on track.
All right. What kind of problem are we going to do now? Similar to the last one?
Right, you can do the same as the last one, just do it the different way now.
Sure.
Was it 562?
That's okay. You can take your 3. No problem.
Yeah.
Make a new one. 362. All right. So what are we going to do now?
3 goes into 3 ones.
Okay.
So 3 times 1 would be 3. Bring down the 6.
Good.
And it goes in twice. 3 times 2 is 6. And bring down to 2.
And so this part that you're doing over here on the right-hand side, right? This is just showing that you're doing 3 into 6, kind of like a division part right there.
Yeah.
Gotcha. Okay.
But it doesn't go in, so that would be remainder 2.
Nice job. And I like the fact that you looked at this and said 3 doesn't go into 2 at all. And instead of quitting and saying, okay, we're done, then you said, hey, 3 doesn't go into 2 at all. We have to put that 0 there, right? Okay, you got this answer. Let's see you check it. Make sure it's right.
0 times 3 is 0.
Good.
2 times 3 is 6.
Yep.
3 times 1 is 3, plus 2, which equals 362.
That's it. Exactly right. And I like how you added that remainder in there too, because you got to add that back in at the end. Otherwise, 360 isn't quite there.
Yeah.
Well done. So 2 different ways to divide today. Nice job.
There you go. Well done. And I like how when Scott was saying that you put that 0 up there, because a lot of
Super
students
important.
will see 3 doesn't go into 2, and like you said, stop.
Right.
And then they'll have 12 remainder 2. And if you don't verify the answer, you'll leave it as 12 remainder 2.
Yeah.
And then when you get it back, it's wrong, and you're like, but I know I did all the steps. Look at, here's my work. And you just have to remember to put that 0 up there for that placeholder right there. So, Love, you were able to show us 2 different ways to do your division problems.
Yes.
Is there a way that you prefer over the other?
I like the regular division better.
So the one that you just did? So why do you like that better than...
I'm more used to it, and it's easier for me.
Okay, so you're used to that way, and you're more comfortable with it, it's easier for you, and things like that.
Yes.
Now, do you think, because you've shown us 2 ways, do you think there's a 3rd way to divide?
I don't think so.
You don't think so? Well, you know what? That's going to be something for you to research, because there's going to be a 3rd way for you to divide, and guess what? What do you think is going to come after that? A 4th way to divide. So there's going to be a lot of different things you'll be learning as you go through school. Hey, we do have phone tutors available until 5:30 this afternoon. We'll go out and visit CRC one last time with Devin.
Hey, thanks a lot, Mike. Wrapping up the day here at California Resources Corporation live with one of our friends, Reservoir Engineer Shane Myers. Shane, thanks for joining us today.
Thanks for having me.
So we talked to Creedy about projecting production rates out of a single well for a month and some of the math that went into that. And we can kind of extend that bigger picture with some of that information.
Correct.
And using a lot of the visuals that a lot of the systems you've put in place as a company, we can put some deeper projections in. So kind of walk us through what we're looking at
Yeah,
here.
sure. So Creedy focused on a single well with a single value per month. So what you're seeing here on this map, this is plotting oil as green, gas is red, and water is blue, essentially showing an area of 2B of kind of our varying rates per well. So essentially, we're trying to look at these and figure out what's it making, can it do better, can it do worse, and kind of compare why are they varying.
So this is your way of
Correct.
seeing how a variety of wells at the same time are producing at different rates.
Correct.
Okay. So then we'll take that information, and the computer's going to process that into some projections long term with
Yes.
some of these graphs over here.
Yeah, so you can see this well is a well that's on since 2013. So you can see kind of it came on about 30 barrels a day, and it's been producing for about 4 years, and now we're down about 20. So it's declined about 12% or so per year.
So each of these sections represents one calendar year. So
Correct.
this would be 2014, this would be 2015. So this is kind of where we are. We're about 3/5 of the way through 2017. So the end of this line is right here, right now.
Correct. And so we keep data up to date, and it's actually potentially current, so it's all coming in real time.
And so we're able to kind of use that information longer term. And so you kind of laid this out as far as what the computer is going to calculate here. So how do we use this information to make decisions, and what exactly are you looking to find?
Sure, yeah. So this is kind of just zooming out a little bit. So this is, like I said, one well. And so what we're going to do is we have to try and fit a curve to this data. Do you see, can we match what we currently have and then forecast what we'll be seeing going forward? So to do that here, so one equation we'll use is called exponential. And so on a semi-log plot, it'd be essentially a linear line. So we're seeing here. So now we can, going forward, we can kind of know what to expect our rates to be in the next days, months, years. So if we start, going below that, we can go in and do work and bring it back up.
So I'm seeing a couple of really interesting things right here. One of which are all of these points that are represented. We have this projection line, and if you're in 8th grade, you would recognize that as a line of best fit.
Correct.
which is going to be a good projection of the overall trend of this line over time, even when it's not a smooth, perfect function.
Yes.
And so with that information, we're not only able to predict the trend for any exact point in time, but bigger picture as well, we can find out kind of what's underneath that.
Correct. So if you look at the area underneath this curve of our history, this is our cumulative data, our production we've made so far since the well has been on. And, trying to look at value of what our well is going to bring us, we can also, forecast out for the rest of the life of the well and determine kind of what's the amount of volume we're going to make of oil to kind of figure out our cash flow going forward.
So if you're in 8th grade at home and you see this, and this is kind of making a little bit of sense to you as far as the area of the space under that projected line, what we're really looking at here is calculus. Calculus is all about finding out the space on a graph and figuring out what that means. So, even with that, we can almost see this as a projected triangle or different parts here to figure that out. And you have your systems to do that. But, when we think spatially, this is a big jump that a lot of our kids are going to be able to access through this understanding of how to use the visuals. And that's been a big connection, and it really drives a lot of what you guys do with California Resources Corporation.
Correct.
So, it's wonderful to see, and it's been great to be able to join the team here. I wanted to bring Nathan Reich back in here as well for his work this afternoon. And Nathan, again, thank you so much for allowing us into the walls of the building here. We wanted to, again, commend you and your team, and thank you for your help and support with Do the Math, as we do customarily here with our traditional ceremonial tile. And thank you again for the professionalism that your team has been able to use to communicate the work that you do with the company.
We were happy to do it, and we appreciate you guys coming on site.
That'll do it. We're here from California Resources Corporation. We're going to send it right back to the studio. Mike, we'll see you next time. Back to you.
All right, nicely done out there, Devin, and a big thanks to Nathan. I know that Nathan and I have been communicating over this for a couple of seasons now, and we finally were able to get everything to work together. So we certainly do enjoy and appreciate all of the staff out at CRC sharing their knowledge and what they do and how they apply math to it. So
a lot of math going on out there.
thank you once again to our friends out at CRC. Hey, you know what? If you've not yet received your stickers at your school, and you'll know what we're talking about here when you take a look at the stickers right there, because a lot of students have these already, or they have the binder dividers. If you have not yet received those, or you need more of those, simply give us a call. The phone numbers, as always, are at the bottom of your screen. Just let us know what school you're at and how many more stickers you need. So you might be just a student in there, or you're an educator there, and you're like, hey, you know what, we gave them all away, a lot of parents want them, and we need 500 more. Well, let us know, we'll send out 500 more. All right, young lady, last thing of the day. You need to find out who's going to CSUB Athletics. Pull out one of those names and let's see who it is.
Morgan.
There you go. So Morgan, congratulations, a 6th grade student at Lum Elementary, going to CSUB Athletics right there. So nicely done. We thank Love for coming in today, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.